This isn't just another update about batteries, it's a turning point where the future breaks away from the past. For years, lithium has quietly powered our phones, cars, and even homes. But behind its dominance, serious issues have been growing. Rising costs, safety risks like fires, and heavy dependence on limited global supplies. Now, something new has emerged from Tesla's most secretive labs, something that could completely disrupt that system. This new battery isn't built on scarce resources, but on abundance. It's not fragile, but strong. And instead of merely competing with lithium, it has the potential to replace it entirely. So, is this the end of lithium's era or the start of something even bigger? Tesla's aluminum-ion battery isn't just an alternative, it represents a complete shift. At its core is a simple advantage. Aluminum ions carry 3 positive charges, while lithium ions carry only 1. This means aluminum can deliver 3 times more energy per ion, boosting energy density without requiring complex materials or engineering. Safety is where aluminum truly stands out. Lithium batteries can form dendrites, tiny metal spikes that can pierce internal layers and cause fires or explosions. Aluminum-ion batteries don't form these spikes at all. They remain stable across a wide temperature range from -40 degrees Celsius to 85 degrees Celsius, far beyond what lithium can safely handle. This eliminates the risk of thermal runaway, reduces fire hazards, and removes the need for expensive cooling systems. There's also the issue of supply. Lithium is limited and concentrated in a few regions, making it expensive and geopolitically sensitive. Aluminum, on the other hand, is the most abundant metal in Earth's crust. It's widely available and easier to process. Plus, aluminum batteries don't require cobalt, addressing one of the biggest ethical concerns in the electric vehicle industry. When you look at chemistry, safety, and availability, aluminum doesn't just improve on lithium, it makes it outdated. In terms of performance, aluminum-ion batteries go far beyond lithium's limits. Traditional lithium batteries reach about 250 watt-hours per kilogram. Tesla's aluminum-ion cells are said to exceed 5,000 watt-hours per kilogram. That's not just an improvement, it's a complete leap forward. A car like the Tesla Model 2 could potentially go from a range of around 330 miles to over 3,000 miles on a single charge. Lifespan is another major breakthrough. Lithium batteries typically last around 2,000 charge cycles, which translates to a few years of regular use. Aluminum-ion batteries could last over 50,000 cycles, enough for several decades. This is possible because their electrodes can repair themselves. The tiny cracks that normally degrade lithium batteries are automatically fixed in aluminum cells, allowing them to maintain strength over time. Charging speed is also dramatically improved. Lithium batteries usually take close to an hour to reach 80% charge. Aluminum-ion batteries can reach a full charge in about 10 minutes without overheating. This is because aluminum ions move faster and generate less heat during operation. Safety improves even further. Aluminum batteries are non-toxic, stable, and don't catch fire or explode. In contrast, lithium batteries have been linked to thousands of electric vehicle fires. Aluminum technology removes that risk entirely. Across every key area, energy capacity, speed, safety, and lifespan, aluminum-ion batteries don't just compete with lithium, they redefine the standard. Beyond performance, aluminum-ion technology unlocks features that once seemed impossible. One of the most remarkable is its self-healing electrode system. Tiny cracks that would normally damage a battery are repaired within seconds. Studies show this process can restore up to 99.7% of the battery's original structure, and in some cases even improve performance by creating more efficient pathways for energy flow. In simple terms, the battery doesn't just recover, it can actually become stronger. Another breakthrough is in power storage. A single aluminum-ion Tesla battery could store up to 2,000 kilowatt-hours of energy, enough to power multiple homes or even entire job sites. This transforms the battery from just a vehicle component into a mobile energy station. Tesla's intelligent survival mode could distribute this energy during blackouts or emergencies, keeping essential systems running for weeks. Perhaps the most surprising feature is its deep sleep mode. Unlike lithium batteries, which slowly degrade when left unused, aluminum-ion batteries can enter a crystal-like state of stability, preserving their performance over long periods without loss. It loses almost no capacity even after 10 years, and when it's brought back into use, it becomes fully operational in just 30 seconds. These aren't small upgrades. They represent entirely new capabilities. This shows that aluminum-ion isn't just a better battery, but the beginning of a completely new era in energy technology. Before we go further, don't forget to hit the like button. It really helps this video reach more people. Thanks for your support. Now, let's talk about how aluminum-ion batteries could make electric vehicles truly affordable for everyone. This technology doesn't just improve batteries, it changes the entire economics of transportation. Lithium batteries have made EVs expensive, delicate, and out of reach for many people. Aluminum changes that completely. It's the third most abundant element on Earth, and that availability brings stability in cost and supply. A 50 kilowatt-hour battery pack that once cost up to $7,500 with lithium could now cost between $2,000 and $4,000 using aluminum-ion technology. This one change alone could reduce the overall cost of an EV by as much as 20%. Recyclability is another major advantage. Lithium batteries lose efficiency each time they're recycled, but aluminum-ion batteries can retain up to 95% of their performance even after multiple recycling cycles. This lowers long-term costs and reduces waste significantly. Tesla clearly understands the potential. The upcoming Model 2, expected to start at under $15,759, is designed to dominate the mass market. It won't just be more affordable, it's expected to outperform others in its category, offering over 400 miles of range and a full charge in under 15 minutes. Most importantly, it could last a lifetime, with a single aluminum-ion battery pack lasting up to 70 years. No replacements, no fire risks, and no compromises. This isn't just about affordability. It's about removing the biggest barriers that have held EVs back. So why is 2025 being called the start of a new battery era? Back in 2022, Elon Musk hinted that things would accelerate dramatically, and now that moment seems to have arrived. After nearly 7 years of quiet development in Tesla's Nevada lab, aluminum-ion batteries are finally ready for large-scale production. This isn't just speculation. It's becoming reality. Tesla has reportedly already started production, and insiders suggest a full reveal could happen soon, possibly during Tesla's expected Battery Day event. The timing couldn't be more important. Lithium supply chains are under pressure, prices are unstable, and governments are tightening regulations around mining. At the same time, consumers are becoming frustrated with EVs that are expensive, slow to charge, and come with safety concerns. Aluminum-ion technology addresses all of these issues at once. It's arriving exactly when the world needs a better solution. If Tesla unveils a fully ready aluminum-ion battery soon, the following year could mark the moment when electric vehicles truly go mainstream. Not because of incentives or hype, but because they finally become practical for everyday use. This isn't a slow transition. It's a decisive shift that could leave the old technology behind, and the impact goes far beyond just better batteries. This isn't only about aluminum replacing lithium. It's about changing how we think about energy, technology, and independence. While lithium has driven progress, it has also brought environmental damage, geopolitical challenges, and limited accessibility. Aluminum-ion technology changes all of that. Energy could become stable, safe, and widely available, and the possibilities go far beyond cars. A battery that lasts decades, charges in minutes, and can power a home for weeks could transform entire communities. Remote areas could operate without relying on traditional power grids. Disaster zones could recover faster with portable energy solutions. Industries could completely rethink how they store and distribute power. For everyday consumers, the most expensive part of an electric vehicle, the battery, would become the most reliable, affordable, and sustainable part. Tesla isn't just building a better product. It's quietly reshaping the entire system built around lithium, cobalt, and even fossil fuels. Industries worth billions, centered on mining and processing these materials, could face a massive disruption in the years ahead. Companies that fail to adapt will simply fall behind. The aluminum-ion battery isn't just another innovation. It's a complete reset, setting a new standard for the future. When we look back, 2025 won't be remembered as just another step forward in battery technology. It will be seen as the year energy itself was redefined. The real question is, what happens next, and who gets left behind? The race has already begun, even if most people haven't noticed yet. While many automakers are still trying to improve lithium batteries with small upgrades, Tesla is preparing to move far ahead with a technology that could change everything. Aluminum-ion batteries are no longer just experimental. They're moving into production, supported by existing global supply chains and decades of aluminum infrastructure. This gives them a huge advantage. They can scale quickly, much faster than lithium ever could. Meanwhile, companies that continue to invest heavily in lithium technology may be heading toward a risky future. They're building on a foundation that's becoming increasingly unstable. Lithium prices are unpredictable, and supply chains are tightening, making it difficult to ensure long-term affordability or competitiveness. Once Tesla's aluminum-ion batteries hit the market, offering lower costs, greater safety, and longer life, the rest of the industry won't have years to catch up. They'll have months. Consumers are likely to shift quickly. After all, who wouldn't prefer a battery that doesn't need replacing, doesn't catch fire, and charges as quickly as grabbing a cup of coffee? This isn't just a new feature, it's a whole new expectation. At this point, the question isn't whether aluminum-ion technology will take over. It's about who is ready to embrace it and who is still holding on to a technology that's already becoming outdated. This isn't a slow transition. It's the rapid fall of an old system. Lithium had its moment, but its limitations have become too significant to ignore, from safety risks to rising costs. With Tesla's aluminum-ion breakthrough, we're not just starting something new. We're closing the chapter on what came before. Safer, faster, more affordable, and more durable, this technology has the potential to reshape not just vehicles, but homes and entire energy systems. The shift is already underway. The real question is, will you just watch it happen or be part of it? The end of lithium isn't something coming in the future. It's already happening.